this is coaxial cable that I'm holding in my hand. Before we go too far, just come in and gather around. Ethan, come over here. The coaxial cable, this particular coaxial cable is 50 ohm. 50 ohm, that's a nominal impedance. That doesn't mean if I get a multimeter and I measure across the terminals I get 50 ohms. No. There's another factor in electronics called impedance, and that's an AC term. And with impedance, at specific RF frequencies going through the cable represents a 50 ohm impedance. The particular cable, if we think about the schematic diagram, it's got a outside braid which represents ground, and then it's got an inside active terminal. And when we cut the coaxial cable, I'll just pass that one around the room. That's one that I've already prepared, so I'll pass that around. I want you to have a bit of a look at it. There's a few different ways that you can cut this cable for what we want to do today. Now, the way I'm going to demonstrate is with a nice sharp blade, and you've got to be a little bit careful. You want to bring the camera a little bit closer there. I'm going to cut off the length that I want to make this a bit easier for me. I'm going to cut about 50 millimeters, little strip, and I'm going to roll that cable around with the blade on top. And I was very careful there to make sure that the blade hasn't gone right down to the metal wire, which is the shield inside the cable itself. Otherwise I'll start cutting through the shield and breaking some of those strands, and I don't want to do that. So you can see there now I've bent that, and then that black plastic tubing on the outside has split, and it allows me to see the shield inside. Now, without slicing my fingers open, I'll run down along the cable sheath. Again, I was very careful not to go too far that I damage any strands. So probably a bit of experience helps there, because I can sort of feel how deep I'm going with my knife. Using a very fine tool here, you can get these with a bit of a coarse point on the end or a very sharp point on the end. I prefer the little sharp point here, and I'm going to spread apart this shield right up next to the plastic. And this takes a little bit of work. You just got to go slowly at it. I don't want to break any of the strands if I can help it. And the idea is that I'm going to be bending that down, getting the sharp point underneath the inside plastic insulated core, and then we're going to pull that through the hole that we make. If you've got any questions while I'm doing this, just feel free to ask. For example, why are we learning this? Whereabouts are we going to use it? Nobody thought to ask that question? Well, the syllabus requires that we do some work with a shielded coaxial cable, and today we'll be using this from one of the collectors on the multi-vibrator board to the pulse width limiting board. Lots of interconnecting cables in real electronic circuits are done, in fact, with coaxial cable like this. So now I've taken my time and I've made sure there's no strands in the way, and very carefully now I'm going to be pulling the inside core up and away from the shield. It takes a bit of work because the shield is actually fairly tight on that core, and sometimes you can loosen it up by pushing it in like this. Make it a bit looser. Here we go. we're up. I've broken 2 strands and only 2 strands only. I'm pretty happy with that. Cut those 2 strands off. If I'd broken any more than that, it would have been a failure and I'd be tempted to start again. Then just flatten that out with my fingers, and that's the outside braid now, free of the inside core. Finally, again being very careful not to break any of the individual strands of wire inside here. Cutting about 10 millimeters of plastic off the end, only pressing enough on the plastic to be able to free it. I do not want to break any of the strands inside. Natural lay of the wire, twist it around, and there we have it, done.
So is there a reason why the braid is kept as a braid?
Like this?
Yeah.
Oh yeah, because we want maximum conductivity. If I was to hack around here and then pull away the metal from the outside and then wrap it around together, 1, I'm going to break some strands in it, and 2, it's going to look ugly, and 3, it's going to be a bit difficult to solder, and probably 4, it's, most importantly I guess, it's not going to have that flexibility that the braid has. Because when this is soldered, we only want to solder the very end. Then we've still got some flexibility. And I suppose that's a good question that Dave asked. When this is mounted onto the board, we have to think about putting some sort of a link over the top of that to hold that firmly onto the board, because the soldered wire itself you can't rely on for physical support, because with any movement that will simply fatigue the wire and break away from the soldered joint. So you're going to use a piece of coaxial cable about maybe 200 millimeters long, and you're going to strip each end. One end is going to go to the collector terminal on your multivibrator, and one end is going to go into a capacitor on that pulse width limiter board. Are there any other questions about the coaxial cable?
Where does the braid go to ground?
Braid goes to ground, yes, as per the little drawing that I've done here. Now, I started off with 10 fingers. I've still got 10 fingers, and there's no tomato sauce on the front desk. You know what I'm saying? All right. Please be extremely careful with the knife while we're doing this. Okay, good luck.